afternoon. Afternoon all. Afternoon, Mr. Bishop.
Good afternoon, Ms. Davies. Welcome back to another episode of Bish Dog, Davies Dog Maths. Today we've moved on from linear equations. Next step is quadratic equations. Okay.
Nice. Yep.
So linear, a straight line. This one, it's a bit quadratics, Angry Birds. Okay. Curves.
Angry Birds curves. Okay, I like that. Yeah.
There we go. Parabolas, up, down.
Yep.
You know, the steeper the piggy goes up, the steeper the piggy drops down.
Right, there you go. That's a good one. Yeah, I do
Well,
like
the birds fly and kill the piggies. Sorry. Yeah. You haven't played
Anyway,
that game, have you?
that's right.
To this. A couple example equations. These have been given out before on graph paper. You may recall this one.
Which we'll also put up onto Connect again for people if you haven't got it.
Sure.
Yep.
But one of the examples is not the easiest, but not the hardest. Y equals x squared plus 2.
Okay.
So, it's just making plots on the graph for starters. So, they give you x, but it says what y equals if x is a certain number. Alright? So, for the first example, x is negative 3. So, what does y equal? Well, y would equal x squared plus 2. Now, it's important to remember, a negative, squared means the number times itself. So that's like saying negative 3 times negative 3.
Negative 3 times negative 3, yep.
Now, you really got to know your negatives and positives here. A negative times a negative is a...
Positive.
Yes, it's like me giving you a chocolate bar and saying, don't not eat it.
Don't not eat it.
Two negatives. So what would you end up doing if I said that?
You'd be eating it.
Eating it.
Yeah, you would.
It's a double negative,
Yeah.
so it becomes
Definitely.
you'd have to eat it.
Yep,
So we all know what 3 times 3 is.
So 9.
9.
9, it's 9.
Which so then if it's negative 3 times negative 3.
So it's a negative times a negative, so it's a positive.
Yep.
So it's negative 3 times negative 3 is positive 9.
So yeah, it's the same.
Positive
so
9.
That's 9.
Right, okay. Yep.
And then, so that's that bit done. So for this bit only, that would be 9.
Yep.
And then plus 2.
9 plus 2 is 11.
11. Okay, so that's, screw up that. New board, by the way.
Brand new board.
You get to see that when
you get back.
11.
Beautiful.
Okay, so the same thing, negative 2. So the same as 2 squared would be 2 times 2.
Which is 4.
4. But then it's not much different to negative 2 squared because negative, positive. So it's also 4.
So positive 4 because it's negative 2 times negative 2 is positive 4. Okay. Yep.
4 plus 2.
Yep. 4 plus 2 is 6.
Okay.
Awesome.
The tricks, you think it's easier, but it's actually confusing a few kids. 1. Negative 1 squared. So the same as 1 times 1 is
1.
Yep.
It's 1.
Quite often you get different answers, but yeah, it's 1. 1 plus 2
is 3.
3. Now what's 0 times 0?
0 times 0. If we've got nothing, then I times it by nothing, then I'm going to have nothing.
Bit like my bank account.
Oh.
Nothing. All right. Plus 2
is 2.
Yeah, that's true. You started from 0, but you plus 2. You still have 2.
Awesome.
All right. Yep. And now you know something. 1 squared. 1
times 1 is 1.
Yeah.
Yep.
Plus 2
is 3.
3.
Yep.
Yeah, there you go.
Okay, look at
and
that.
2 squared
is
4 plus 2
is 6.
6. And 3 squared is 9.
Yep.
Plus 2 is 11.
11.
So you notice we go down, hit the bottom there, and then we go back.
And it's interesting that this is 11. That's 11.
Yeah, so
this is 6, 3, 3, and then 2 in the middle.
You
so it's
parabola, doesn't it? Yeah.
So it's a nice.
Okay.
So if we were going to plot that, where would the y-intercept be?
Well,
y-intercept. Where's the y-intercept, Mr. Bishop? Do we think?
I think.
Where does it cross the y-axis? What's the x value when it crosses the y-axis?
I would go for the 2.
2, yep, because x is 0, y is 2, so x is 0, and here y is 2, so I'm putting a bit of a dot there. Yep, on the 2, okay. Yep.
Yeah.
And then what would be the next thing we do, Mr.
Well, this is how you do it. I always start from here, just
Yeah, you could start that way as well. So you can go down to -3.
Yeah, but if you got a better way.
No, not necessarily.
Okay.
What's our limiting? I mean, there's a limiting issue here that I hadn't thought about before we did the coefficient plane.
That's fine. That's a good point. This comes up in these lines going forever. Okay. Y equals x squared is not limit. It's not a stop point here and a start point here.
We've just chosen.
It's just the curve. So the curves go up into space. They go on for infinity. But just for the x values we gave you, where is the curve? So the dilemma here is we've come up with this value 11, and Mr. Davies' graph does not go up to 11. So that's going to happen in worksheets and stuff all the time. If you can't do it, don't do it.
So what I might do here though is I'll just grab 9, 10, 11, like it's right at the top of the board.
But either way, like if it's not there, it doesn't matter.
If it's not there, it doesn't matter.
You can't do it.
We can't do it. But for what
we've extended it.
We extended it here, so we'd go -3 up to 11, which is there. So this is a sketch. If you're doing it on graph paper, Mr. Bishop, it's much more accurate. If you're doing it this way, it's a bit more difficult, isn't it? Yeah. Okay. So what would the next number be, Mr. Bishop?
I've got negative. You've done the first one?
Yeah.
-3, 6, 11, cool. -2 and 6. So -2.
-3, 11.
Yeah.
Put brackets around it, that's that point. And then we've got
-2, 6.
6. -2, 6. In here.
So negative gone that way, cool.
-2, 6. Yeah.
And then -1, 3.
-1. -1 here for x. Y is 3, so it's in here. Of course, if you've got graph paper, it's much easier. Yeah.
0, 2.
0, 2, which was that y intercept we talked about. Yep, 0, 2. So 0, 2. Yep.
And 1, 3.
1, positive 1 this time.
Yeah,
positive 1, 3. Yep, so that's there. So 1.
And then they'll start to mirror the lines.
Yeah,
so 2, 6.
2, 6 here. 2, 6. And remember when you're writing these, and I'm just doing this to demonstrate for the cameras today, but x is 1, y is 3, x is 2, y is 6.
X always goes first.
Yep.
You guys know that by now. 3, 11.
3, 11. So 3 and 11. So it's right at the top here. Okay. And this is the real tricky bit, is the whole sketching of the graph, because you don't really want to get a ruler and join the dots. You shouldn't do that. It should be more of a sketch of it.
Yes.
Because it's a curve, and it can look a bit problematic and a bit wonky.
Yes, but it is a curve, because you got to remember, it's not that value and then straight to that value. We could put in what's 2.2.
2.2
squared
2.2.
plus 2, and that would have to fit in along this line as well. Okay?
Yeah, it would
so
correspond with a dot.
I mean, I would probably, to be honest, I'd give that a bit of a fatter.
There you go. Fatter bottom on it.
Fatter bottom, yeah.
Yeah. And then that would probably come sharper up to
here
without
but
this
I mean,
bulging
there's no right answer, but yeah, it's got to be as least jerky as possible. But
and nice and smooth. But I mean, the most important thing here is getting the coordinates right and making sure that it kind of looks like a parabola, that you don't have.
But between they're the whole numbers, but in between them, each one of those values, like you had 1.7. That squared plus 2, that should be able to fit on that line. So that's why it's not just point to point.
And of course, it's continuous data because it's a line.
Yeah, and it'll go on.
Yeah, and off it goes. Okay, so that's that one. So we'd write, I'd kind of say, well, y equals x squared plus 2. If I were doing graphing on a nice bit of A4 paper, it's a bit hard to see probably from the cameras here, but you'd probably label the graph anyway.
Yeah.
All right, so we have a look at the next one, Mr. Bishop. What do you reckon?
Bit harder again. Y equals x squared plus 2x, so that's 2 times whatever x is, then plus 3.
Yeah, right, that's full on.
So that's x times itself.
Yep.
And then that's 2 times x plus 3.
Plus 3, okay. So if we were going to go start down there at -3.
So -3, we've done that up here, should be familiar with it. -3 squared is...
-3 squared equals...
9.
9.
That before, negative times negative, so it's positive.
9.
And then this is where... So we got 9, you got that. Now this is 2 times whatever x, so 2 times -3. So this is a positive times a negative.
Positive times a negative, okay.
So that's positive times a negative is a
negative.
Yeah, when there's two different things, positive is positive, negative is positive. But when they get two different ones, it's negative.
Negative answer. Yep.
So 2 times negative 3 will be negative 6.
6. Okay.
So,
yep.
Plus 3. So we go. We've got three operations there. So we go 9 plus negative 6.
So
now
plus
I
and
don't know.
negative 6.
Maybe might just move the tripod here. Oh, here's my timeline. It's been around a while. I've got up here. Here's the directions. Taking a negative ends up being a positive. Okay. We're not multiplying here, we're adding and taking. And adding a negative ends up being a takeaway.
A negative.
There.
Okay, yeah, taking it away.
So we're going 9 plus negative 6 is what we've got here. So that's 9 plus negative 6. So this is just for this dot only. Excuse the camera work. Plus
Negative 6 plus 3.
So that would be you're starting at 9. Now we all know when you're plussing a negative, it becomes a negative. So basically we're taking 6. Do you agree, Mr. Davies?
I think so, yeah.
So we start there, go backwards 6 spots. 9. 1, 2, 3, 4, 5, 6. Always draw a number line if you're confused. So now we're down to 3.
Yep, down to 3.
Okay, and then it's...
We're up here, we're down to 3.
And now we just have to
add
3.
Add
so
3.
Go back 3 spots. 1, 2, 3.
Wow.
So that's there's your final answer. 6.
6. Okay. 6 is the answer. That's good. So where would we put that 6, Mr. Bishop?
Oh, there you go.
There you go.
Yeah,
Look at that.
We won't be able to speed it up a bit now.
Excellent.
All right. Because that just applies to that one coordinate.
Yes.
So now negative 2 squared is 4. Then we got 2 times negative 2, which will be negative 4.
So plus negative 4.
Yep.
Yep.
Plus 3.
Plus 3. So 4 plus negative 4. Plussing a negative 4 was takeaway.
So you're at 4, then you take 4, you're back to 0, and then you plus 3, we're back to 3.
3. Okay.
Okay.
3. We'll do the next one.
Negative 1 squared is 1.
1.
Now plus 2 times negative 1, which would be negative 2.
Okay, so it'll be 1 plus negative 2
Plus 3.
plus 3. So plus negative 2 is takeaway.
Yep.
Okay,
So
so
1, and then we
take
go
2,
back 2,
plus
which
3.
gives us negative 1.
Yep.
And then we go forward 3. 1, 2, 3, which gives us 2.
2. Okay, so we're at 2.
You don't have to have a fancy number line. I don't know if that's in view, but just write it 0 to 10 that way, negative 10 that way. It always helps.
Number lines are very good.
Yep.
0.
0. 0 squared is 0 plus 2 times 0. What's 2 times 0?
0.
Yep, 0.
Yep, so that'll be 0 plus
Yep.
0 plus 3.
3.
Yep, which gives us
3.
3. Okay, cool.
Okay, and then 1 squared is 1 times 1 is 1.
1
Plus 2 times 1 is 2. Plus 3.
Plus 3.
So
1
1
plus 2
plus
plus
2
3.
plus 3 is 6.
6. Cool.
Yeah. 2, here we go, 2 squared is 4.
Yep.
Plus 2 times 2 is 4. Plus 3. So 4 plus 4 is 8. Plus 3 is 11.
11. Nice. Very good maths, Mr. Bishop.
And then last one, 3 squared is 9.
Yep.
Plus 2 times 3 is 6.
Yep.
Plus 3.
So it's 15.
15.
Plus
15,
3.
18.
18. Excellent. Look at that. Okay.
Now, you notice
Yeah, what's going on there?
the lowest point is not at 0 this time.
No.
Yeah.
So it's dipping down somewhere else.
So you see being x squared, you've still got the 2, 3, 6,
So it's symmetrical.
11. Yeah.
Has symmetry.
Yep. So
Yep.
the curve will find hopefully similar. Yep.
Okay, so at -3 we've got 6. So at -3, I've got. And what I might do is use a different coloured whiteboard marker.
Black. I'll use the green. Green, good choice.
-3 and 6. Putting a dot somewhere there.
Yep.
Okay.
-2 and 3.
-2 and 3, which is here, and I'm sort of interfering with my other parabola, but that's okay.
Good comparison.
Yeah.
-1 and 2.
-1 and 2. Yep.
0 and 3.
0 and 3. So that's that y-intercept we talked
Yeah.
about. Yeah.
And 1 and 6.
1 and 6. Yeah.
And 2 and 11.
2 and 11, the old 11 chestnut we had before.
Yeah.
Okay.
And
And
3 and 18, but yeah.
I'd be in trouble, I
Yeah,
think, wouldn't I,
but
Mr. Bishop?
yeah,
I think
we
we'd
don't
be
have
swimming
to.
outside the
We
flags
don't
doing that. So we better not do that.
That's not necessary.
Okay, so how about we join the dots, and
Yeah.
perhaps I'll give it a crack this time and see if I can make it look like it should look.
Yep.
And we draw an arrow on each end because, as you were saying before, Mr. Bishop, it goes off into infinity.
Yeah.
It goes off into space, effectively. Yeah. Okay, so that's our. We would say that that's the other graph, which is y equals what were you going to say? Sorry, Mr.
Y
Bishop?
equals x squared plus 2x plus 3.
+3. That's the other one. Okay.
Yeah. So you can see the
Awesome.
curves identical,
Yeah.
but it's shifted.
And in fact, that might need a. I just use a blue one because I think it's probably a bit darker. The blue, because you may not be able to see that on the camera as easily. That's that graph there. Okay,
Alright.
so it's shifted over, and the reason why it's shifted over is because of this +2x bit, and we'll get to that a bit later as to why that happens. We'll talk about that probably in the next video.
Next video, so we're done with this video.
What do you think? We done?
Yeah, that's great. There's
Awesome.
obviously more coming.
Any questions? Jump into comments on Connect.
Yeah, and
Send some
we'll
stuff
put a
through.
discussion form up.
Yep.
Or if YouTube, you can put it in the comments if you're not from Clarkson High School.
Yeah, if you're from elsewhere and you'd like to do some learning.
You can come and enroll.
Yeah. Awesome.
Yeah, signing off. Thanks.
Thank you, Mr. Bishop.
Thank you, Davies.
Have a good day. See you guys.